Hello dear students, welcome you all for Power System Operation and Control class. Continue with the mathematical model of ALFC. Today we will see one problem on this and few of the theory parts which is remaining in the first half of the third module. So this is the problem which is asked in the question paper itself. Here a single area consists of two generators with G1, that is generating capacity is 200 megawatt with regulation of 4% on machine base, and G2 is 400 megawatt with regulation R is equal to 5% on the machine base. They are connected in parallel and share a load of 600 megawatt in proportion to their ratings. At 50 Hz, 200 megawatt of load is tripped. What is the generation to meet the load if D is 0, and what is the frequency at the new load? Repeat the same thing for D is equal to 1.5 per unit. So the problem will refer graphically, previously was solved one. So initially we'll choose that base of 200 megawatt with D is equal to 0. Then R1 is on the 200 megawatt base only, obviously that is 4% means 0.04 per unit. R2 we need to find out on the base of 400 because it is there in the 400. We need to convert it for the 200 megawatt base. 0.05 is means nothing but into divided by 400 into 200. So that is what 0.025 per unit on 200 megawatt base. So delta PL, that is the change. What happens? Drop tripled load is how much? Minus 200 megawatt because it is now a tripled. That's why it is taken in minus. Or on the base itself is 200 megawatt. So we can consider it as a minus 1 per unit. Now delta omega SS is equal to minus delta PL divided by 1 over R1 plus 1 over R2. We know. Put all the values. We will get the values as 0.01538 per unit. So the new frequency at this load is now 50 Hertz is actual frequency, that is 1 per unit. Now the value is 1.1538 per unit, that is nothing but 50.769 Hertz. So then we will be considering what is delta P1, that is minus delta F by R1. So same the delta F is minus 0.01538 divided by 0.04. We will get the minus 0.3845 per unit, that is on the base 200. If you multiply it by 200, you will get minus 76.9 megawatt. Means decrease in the first generator itself is 76.9, that is 200 minus 76.9, that is 123.1 megawatt. Same thing with delta P2 minus delta F by R2, this is coming minus 6.152. so this is directly also we can go with, because if it is minus 3845 is one side, means another side is 1 minus, that remaining thing is 6152. On that base only we will get, but this is actual way. So we will get minus 123.04 megawatt. So total P2 can be known by that 400 minus 123.04, we are getting 276.96 megawatt. Now P1 plus P2 is equal to PL, that is 400 megawatt. Okay, if the same thing is repeated with the D value is 1.5, the changes is now in delta omega SS in the denominator, D will be getting added. Now delta omega SS value will become 0.01504 per unit. New frequency is 50 Hz is the base, multiplied by the per unit value, we will get 50.752. Same procedure is followed. Here we are getting delta P1 as 75.2 megawatt in minus. P1 is 200 minus that one, we will get 124.8 megawatt. Same thing we can calculate delta P2. We will get the P2. Now D delta omega increase the load in due to the frequency change. We will get that is 0.02256 per unit. Base is 200 multiplied by that, we will get 4.512 megawatt. P1 plus P2 is already been known, 404.5 megawatt, and if we are adding that one PL plus the D delta omega, so the sum of the two generators should meet the load plus any increase in the load because of the frequency dependency. So this is what the solution of the problem. The same type of another problem is given here. A control area has the following data: total generation capacity is 200 megawatt, normal load is 1500 megawatt, H is 4.8s, D is 1.2%, F is 50 Hz, R is equal to 2.5 Hz per unit megawatt. So determine the here the things asked is determine the primary ALFC parameters for increase in of 0.02 per unit in the load. Find the frequency drop without governor model, and same thing repeat 2 with the governor model, governor control, and repeat 2 with the governor control, but frequency dependence of the load is neglected. 4 things are given. First thing is what? Determine the ALFC parameters. So D is given by 1.2%, means the load is increases by 1.2% for 1% increase in the frequency. 1% increase in the frequency. So 1.2% of the load is equal to now 18 megawatt into 18 megawatt, that is 1500 into 0.012. 1% of the frequency is 0.5 hertz. So we will get D is equal to D is equal to 18 by 0.5 and 36 megawatt per hertz. So now T of S is equal to 1 by 2HS plus D is equal to 1 by 9.6S plus 0.018. So we will get the equations as this one. You can see here 55.55 divided by 533.33S plus 1. So power system gain we can take as 55.5, and power system time constant we are knowing that 533.33 per unit, or it's divided by 50 will give us the in time S mode domain will get 10.667S. Okay, so without governor control now, without governor control is delta F is equal to minus delta PL by D, or delta PL is equal to 0.02 per unit is given, increase in the 0.02 per unit. So delta F is equal to we will get minus 1.11 hertz. So this is what the frequency drop without governor control. Next C is with governor control. What is that? With governor control means we need to add here minus delta PL divided by D plus 1 by R. Here previous case there is no 1 by R. Here governor control is taken. That's what governor control means. R will come. That is 1 by R. We will get minus 0.0478 hertz. And the last one with the governor control but frequency depends of load is neglected. Then here D is equal to 0. So here only R things will be there. That's what delta F is equal to minus delta PL divided by 1 by R. We will get minus 0.05 hertz. And there is D value here. One note you should see that. Note that here we are using D and R in per unit. That is megawatts per hertz and hertz per unit megawatt. Therefore, the frequency deviations are obtained directly in hertz, whereas the powers are in megawatt. So the way power system gain and the time constant are found out, and the units are used. Can we use D in percentage to solve here? That is a question. So we will find this one here. D is equal to 1.2%. No. Anyhow, on the base 200 megawatt MVA is given, that is D is equal to 1.2 into 1500 by 2000. We will getting 0.9%. So after finding that one, if we want to find the change in frequency without governor control, that is minus delta PL by D, we will get minus 0.0222 per unit. If the 50 hertz is base, so we will get 1.11 hertz is the answer. That is the change in the frequency control we will see. So these are the two problems which is asked in the question paper. Once again you go through the same problem. If you find any difficulties, you can ask me. We will try by your own. In the next class we will go with the transient response and the dynamic response, as well as automatic generation controller, proportional integral controller we will see in the next class. For the time being, you just try these two problems. Okay, thank you.